Hey y'all, this is Christy Fowler from Yadkin Early College. This video is on circles. I am in a secret location. If you can identify where I'm at, you can get extra credit on your next quiz. So the equation of a circle. As we've been reviewing in class, we've discovered that the equation of a circle is x minus h squared plus y minus k squared, which equals r squared. The center point is located at hk. R is the radius. And as with any function that you can graph on the coordinate plane, xy is the location of any point on that particular circle. Now, most of the problems we've been working so far, and some of the things you need to be able to do with those equations, is you need to be able to pull out the center point from a given circle equation. And you also need to be able to identify the length of the radius. So in this particular case, we need to look here for our h and our k values. We have x minus 1. We know that in the standard form it's x minus our h value. So in this case our h value is going to be 1. Okay, so our center point, our center x value is 1. When we look for our k value, we'll notice here that we have a positive 4. So that tells us that when we're trying to identify the point, we have to take the opposite of that positive 4, because standard form is y minus the k. So our center point, the y value is going to be negative 4, not positive 4. Alright, when we're trying to find our radius, we need to take the square root of positive 9, which is going to be 3. So for this particular circular equation, our center point is at 1, negative 4, radius of 3. Now in example 2, things get just a little bit more complicated, but it's all skills that you already know how to do. We're given this equation right here, and this problem might look familiar to you. Okay, so we're given that. Well, it looks like a big jumbled mess. So the first thing you want to do is rewrite it and organize it. Go ahead and put your x's together, and then put your y's together. Now when I say together, I don't mean actually combine the terms, because they're not like terms. What I mean is write them so that they are being added or subtracted from each other. Okay? And go ahead and move that 16 across the equal sign. And we do that by subtracting 16 from both sides. That way we can start the process of finding our radius. Alright, so now once we've got this rewritten, it's a little more organized, we can start actually taking the steps to simplify this and get it into that standard circle equation form. Now in order to do this, we're going to have to complete the square. You know how to complete the square. If you don't remember how, you need to watch the other video on completing the square, but that's all we're doing next. You're going to actually do it twice for this problem. So you're going to do it for your x values, as you can see here, and you're going to also complete the square for your y values. Now, one of the things that was tripping some of us up was the adding of the values over to the right side of the paper there. Okay. When you add the 16 here to complete the square, remember when we were doing it before, when we subtracted the 16 outside the parentheses, it was still on the same side of the equal sign. In this case, we're going to go ahead and add 16 here and add that 16 again here. Since we're taking it across that equal sign already, we're just going to keep the same process. So if we add the 16 inside the parentheses, we're going to add the 16 to the other side of the equation. Same thing with this 9. Okay, we get the 9 by completing the square with the y's, and since we add the 9 here, we're going to add the 9 on the other side of the equation. Okay, so when we factor, we get x minus 4 squared, and we get y minus 3 squared equals 9. Center point, 4, 3, radius of 3. Alright, now let's talk a little bit about arcs and central angles. An arc is simply a portion of the outside edge of a circle. That's it. Okay? A minor arc is less than half the circle. So the measure of an arc, a minor arc, is going to be less than half of a circle. So in this case, arc AB is going to be a minor arc. A major arc is more than half the circle. So you'd be looking at arc ADB in this case is going to be your major arc. A central angle is an angle that has a vertex at the center point of a circle and that connects by radii to the outside edge of the circle. So the central angle in this case is AOB. Okay? Now you can see that the central angle AOB creates arc AB. Alright? Arcs are measured in degrees. So when someone asks you what is the length of an arc, you're going to tell them it's such and such degrees. You're not going to say inches, you're not going to say feet, you're not going to say yards or anything like that. It's going to be measured in degrees. And the arc degree measures are going to be equal to the corresponding central angle measures. So in this case, we have a central angle AOB and the corresponding arc AB. So whatever the measure of AOB happens to be, it will also be arc AB. So you can see down here, I said that the measure of angle AOB is 125 degrees, which means the measure of arc AB is also 125 degrees. Now, an inscribed angle is an angle inside of a circle. However, the vertex is located on the outer edge of the circle. Now, that's real important. For it to be an inscribed angle, the vertex must be on the edge of the circle. It can't be just floating around somewhere in space, okay, inside the circle or outside the circle. It has to be on the outer edge. Now, an inscribed circle is also created and formed by two chords. Chords are simply line segments that connect two sides of a circle. So, AB is a chord, CB is a chord, and those two chords happen to connect at the same point at B, which means that ABC is an inscribed angle. Now, the cool thing about the measure of an inscribed angle, the angle itself, so angle ABC is going to be half the angle measure as the corresponding arc AC. So, if ABC, the angle is, say, 25 degrees, that means that arc AC is 50 degrees. Now, we're going to play around a little bit more with chords. In this case, we have a center point at C, okay, and we have, let's try to get a different color here, okay, we have a chord AB here that goes along the top there. Ooh, sorry, got a little messy there. Okay, but that's your chord AB. All right, now I have also constructed some other lines here. I constructed segment CB, which happens to be a radius, and I have constructed CA, which is also a radius. Now, I've constructed another radius, CF, and you'll notice that I also put in here that that forms a 90-degree angle with the intersection point at AB, of AB. So this, if you remember, is a perpendicular bisector. Okay, so CF is a perpendicular bisector to our chord AB. That's going to be really important because what we've done now is we have created two right triangles. And right triangles are an important part in trigonometry with calculating lengths of missing sides and all that fun stuff. So now that we have a right triangle, it's going to make it a lot easier to do something with that chord, which we want to find the length of the chord. So here's how we go. We're given the information of angle ACB. All right, so let's look at ACB, okay, is 100 degrees. We know that CF is a perpendicular bisector, and we know that the radius is 5 units. Okay? And what we want to do is we want to find the length of our chord. So we're going to have to use some trigonometry. Alright, so here's the information broken apart. I have taken one of the triangles, one of the right triangles, out of that circle from the last slide. You can see I've got triangle CDB, and I stole that from here, CDB. So now I can use some trigonometry. Alright, I know that angle C is 50 degrees because a perpendicular bisector not only bisects that one chord, but it also bisects the angle. So when our original angle was 100 degrees, half of that is 50. So this angle right here, let me get a different color, is 50 degrees. Now I also know that a radius for that circle is 5 units, so that tells me that my hypotenuse is 5 units because CB, if you remember, is a radius. Alright, so then I just set up my trigonometry. Remember your trigonometry, you have sine, cosine, and tangent. In this case, I'm trying to find the opposite side length to the angle that I'm given, and I'm given the hypotenuse. So when I use opposite and hypotenuse, I'm using sine. So set up my equation, sine of 50 equals x over 5. Do my math, multiply both sides by 5. I get 5 times the sine of 50. Put that into my calculator, I get 3.83. Now, since this x value is simply half the chord length, I have to multiply it by 2. So I'm going to end up with a chord length of approximately 7.66 units.